Have you ever marveled at the strength and elegance of titanium? This remarkable metal has found its way into everything from aerospace engineering to medical implants, and even luxury watches. But how is titanium made, and what makes it so special? Let's dive into the fascinating process that takes raw titanium ore and transforms it into the versatile material we use today. Titanium doesn't just appear ready for use, it's extracted from the earth in the form of ore. Most titanium is found in two main minerals, ilmenite and rutile. These minerals are typically mined from open-pit mines, with Australia, South Africa, and Canada being some of the largest producers. The mining process involves heavy machinery to extract the ore, followed by crushing and washing to separate the titanium-bearing minerals from other materials. Interestingly, titanium is the 9th most abundant element in Earth's crust, but it's really found in its pure form. This is because it has a strong affinity for oxygen and other elements, meaning it's usually locked up in chemical compounds. Extracting titanium from these compounds is no small feat and requires a multi-step process. Once the titanium ore is mined, it's time to extract the pure metal. The most widely used method for this is the Kroll process, named after William J. Kroll, who developed it in the 1940s. The process starts with converting the ore into titanium tetrachloride, a volatile and highly reactive liquid. Here's how it works. Preparation. The titanium ore is mixed with chlorine gas and a carbon source, such as coke. This mixture is heated to about 1000 degrees Celsius in a reactor. Reaction. At high temperatures, the chlorine reacts with the titanium in the ore, forming titanium tetrachloride. The impurities like iron and other metals remain behind as solids. Purification. The titanium tetrachloride is distilled to remove any remaining impurities, leaving behind a pure liquid. The next step is reducing the titanium tetrachloride into metallic titanium. This is done by reacting it with magnesium or sodium in a vacuum or inert atmosphere. The reaction produces titanium sponge, a porous, spongy form of the metal, and magnesium chloride or sodium chloride as byproducts. Titanium sponge is far from the shiny, strong metal we recognize. To transform it into a usable form, the sponge must be melted and refined. This is typically done using a method called vacuum arc remelting, VR, or electron beam melting, EBM. Melting. The titanium sponge, often mixed with alloying elements like aluminum or vanadium, is melted in a vacuum furnace. This removes any remaining impurities and creates a homogeneous metal. Casting. The molten titanium is then cast into ingots, which are large blocks of metal. These ingots serve as the raw material for further processing. Forming. The ingots are forged, rolled, or extruded into various shapes such as sheets, rods, or tubes, depending on their intended use. This step involves reheating the titanium and shaping it with industrial presses and rollers. One of titanium's superpowers is its ability to form strong, lightweight alloys. Pure titanium is already impressive, but mixing it with other elements enhances its properties for specific applications. For instance, titanium, aluminum, vanadium alloys are commonly used in aerospace and automotive industries because they combine strength, corrosion resistance, and lightweight characteristics. The alloying process happens during the melting stage. Small amounts of elements, like aluminum, vanadium, or molybdenum, are added to the molten titanium, creating a material with tailored properties. This makes titanium incredibly versatile, suitable for everything from jet engines to prosthetic limbs. After the titanium is formed into basic shapes, it undergoes machining and finishing to meet the precise specifications of its intended use. Titanium is notoriously tough to machine due to its hardness and resistance to heat. Special tools and techniques are required to cut, drill, or shape it without damaging the material. Once machined, titanium products may undergo additional treatments, such as polishing or coating. For example, titanium used in medical implants is often polished to a mirror-like finish and treated to enhance its biocompatibility. In contrast, titanium parts for aerospace applications might receive heat treatments to improve their strength and durability. While titanium is a remarkable material, its production isn't without environmental impact. Mining and processing titanium ore requires significant energy and resources, and the coal process generates waste products that must be carefully managed. However, titanium's long lifespan and recyclability help offset these environmental costs. Many titanium products, such as airplane parts and medical implants, can be recycled and reused, reducing the need for new raw materials. In recent years, researchers have been exploring more sustainable methods for producing titanium. One promising alternative is the FFC Cambridge process, which uses electrolysis to extract titanium from its ore. This method method has the potential to be more energy efficient and environmentally friendly, though it's not yet widely adopted. Now that we've explored how titanium is made, you might wonder why we go to all this trouble. The answer lies in its exceptional properties. Titanium is incredibly strong yet lightweight, resistant to corrosion, and able to withstand extreme temperatures. These qualities make it ideal for demanding applications, from building airplanes and rockets to creating durable medical implants and high-performance sports equipment. Moreover, titanium has a unique aesthetic appeal. Its silvery gray color and ability to develop vibrant, colorful patinas make it a favorite in jewelry and luxury goods. Despite its high cost and complex production process, titanium's versatility and performance make it an irreplaceable material in many industries. Titanium's journey from ore to finished product is a testament to human ingenuity. It's not just a metal, it's a symbol of what's possible when science and technology come together. As we continue to innovate, titanium's role in our lives is likely to grow, paving the way for even more incredible applications. So, the next time you see a titanium product, take a moment to appreciate the complex and fascinating process that brought it to life. From deep within the earth to the cutting-edge technologies of tomorrow, titanium truly is a metal for the ages. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution.